Alright, here is our problem of the day. I don't normally include these in the videos, but I did today. And hopefully you'll make the connection that as n is getting larger and larger, the changes are not happening quite as fast. It's approaching what we call the number e. And it's not a variable e, it's a number e. We're going to talk about that today in a little bit more. So today's topic is the number e, as I just mentioned, and the function e to the x. Today's date, of course, is today. And our objective, we're going to define and apply the natural exponential function. This is actually what we just did in that problem of the day. It would be read as the limit of 1 plus 1 over n to the nth as n approaches infinity. So as n is approaching infinity, n is getting larger and larger and larger. And it never quite gets to where it's going, but it gets pretty darn close. In our case, 2.718 is really going to be about as accurate as we need to be. For example, pi, we don't go out to 10 digits. We usually just say 3.14, even though we all know it goes on further than that. The number e is very similar. It occurs a lot in nature, a lot in science problems. 2.718. It is also referred to, or e to the x is also called the natural exponential function. Right now, we're going to talk a little about compound interest, and then we're going to talk about continuous interest that deals with the number e. For compound interest, when you put your money into a bank or invest it, or if you're making payments, they might say that it's going to be compounded daily, monthly, yearly. And what that means is if it's compounded monthly, they figure out how much interest you make for that month, they put it back into your principal, and then they start compounding that interest on the interest that you've already made. So if it's compounded yearly, they only figure out your interest once a year. If it's weekly, they would figure out your interest 52 times a year. So let's go ahead and talk about what all of these variables mean. P is your principal amount. That's how much you start with. Sometimes you might see that as an a sub naught. R is your annual interest rate. T is the number of years or the time that the amount is deposited or borrowed for. A is the amount of money you accumulate after so many years, including the interest. That looks like it got cut off a little. And N is the number of times the interest is compounded per year. Well, let's talk about N a little bit more. If something is compounded annually, that's 1 time per year, so N equals 1. Semi-annually, happens twice a year. Quarterly, 4 times a year. Monthly, it's 12 times a year. Probably should have put on here weekly. If something's compounded weekly, it would be 52 times per year. And if it's daily, it's 360 times per year. I know the first year that I did this, I said 365, and I realized later that I was mistaken. They use, in the financial world, 360 for compounded daily. The best explanation I can give for that is certain holidays, probably 5 holidays throughout the year. Christmas, Easter, I'm not sure what else. But the main thing to know is N is going to be 360. So let's do a couple problems where we have compounded at different times. I've already had these worked out because this is really just a lot of calculator work. And I'm going to make the assumption that you can put it into your calculator. I'm going to talk a little bit about it, but I think everybody can handle that. So I've got $10,000, and I'm investing it at 6% interest for 5 years. And I want to know a couple different things. How much if I compound it quarterly, annually, daily, or monthly? can't get everything on there, so we'll start right there. So if it's compounded quarterly, that means my N is 4. My initial amount is $10,000 right there. My interest at 6% is 0.06. My N is 4, and my time is 5. The main thing that you want to do is follow order of operations. That's going to be the key. So we have to start with what's inside those parentheses. When I put it in my calculator, I put 0.06 divided by 4 and then added 1. Now I'm going to raise it to the exponent. So raise it to whatever 4 times 5 is. In this case it's 20. And the last thing you're going to do is multiply it by $10,000. I got $13,468.55. Since we're dealing with money, I only kept it out to 2 decimal places. If things were compounded annually, my N is 1. And that makes sense that it would be less than the answer that I got in A, because in A, 4 times a year, I'm making interest on my interest. Compounded daily, my N is 360. And again, that makes sense that I'm going to make the most so far doing it compounded daily, because I'm earning interest on my interest 360 times in the year. And the last one that I did was monthly. Why do I think I just noticed a small little thing right there? That should have been a 12. Let me check my math on that, make sure I didn't put it into the calculator incorrectly. So, 0.06 divided by 12 plus 1. And I'm going to raise that to the 12 times 5, which is 60. And then multiply it by 10,000. Yeah, I got the right answer. I just must have copied it down incorrectly when I was doing this. But in reality, what really happens when you deposit your money in the bank, it's called continuous compounding. The second you earn that interest, it's put back in your principal and it starts all over again. So there's no downtime where your interest is just sitting there. As soon as it's made, it's put back into your principal and you start continuously making money on your interest. The equation that we use there is P of T, which is your ending amount, equals P naught, which is your beginning amount, E, which is not a variable, it's a constant of 2.718, raised to the RT. Ending amount, starting amount, your rate as a decimal, and your time. On your calculator, you're probably going to have to find where your E button is. A lot of times it's where your natural log, so like the second key and then natural log, which is your LN button. In class, I'll probably be going around and helping people with that. So let's do our problem right now. How much would I make if I invest that $10,000 at 6% interest for 5 years if it was compounded continuously? Well, my initial amount is $10,000. Get a parenthesis there. E, and the rate is 0.06. And my T is 5. So in my calculator, I'm going to find where my E button is and raise it to the 0.06 times 5. And when I do that, I'm going to get 1.34985. And it keeps on going. But Gonna leave it right there. Multiply that by 10,000. $13,498.59. Alright, that's all I have for you today. Your assignment can be found on my big campus under the syllabus.